Assalamu alaikum everyone. So today we will be looking at the assays that are used to determine the antioxidant activity. But before going toward the protocol, let's first have a look at some relevant concepts. Antioxidant activity deals with the kinetic of a reaction between an antioxidant and the pro-oxidant or the radical it reduces or scavenges. Now, if you're someone as dumb as me, this must have made you feel a little dizzy. You must be wondering what the hell is going on here. So, in order to understand, let's explore a few concepts here. The ability of a substance to capture free radicals, thus preventing their harmful effect, is known as the antioxidant capacity. Now, what are free radicals? An atom, molecule, or ion with at least one unpaired valence electron capable of existing independently is known as free radical, and they are highly chemically reactive species. Now, how are free radicals generated in our body? The body generates free radical in response to environmental insults like tobacco smoke, ultraviolet rays, and air pollution. And I want you to recall where and how our body generates energy from the food we eat in mitochondria, right? Through cellular respiration. So, what happens in that electron transport chain? Oxygen is utilized to generate ATP, and a bunch of redox reaction, the oxidation reduction reaction occurs there. So, these free radicals are generated as a result of oxidation. And these free radicals, they're not good, guys. We don't want them hanging around in our body. Why? Because they're highly chemically reactive species. They are hungry for electrons. मतलब कि शदीद single होते हैं. They're so desperate. All they want is to grab an electron from somewhere so that the sad, lonely electron that's sitting there in their outermost orbital can find its pair. And then there are like atoms, molecules that our cells are made of. They are living their peaceful and purposeful life, trying their best to keep us alive. So what these restless free radicals do is that they go and poke them. Like, you can think of them as plunderers. They are like, hey, you atom, give me your electron. And there you go, another free radical is generated. Because now that atom whose electron has been stolen now has an unpaired electron. So what do we call species that have an unpaired electron? Yeah, free radical. So that is how a chain reaction starts. Once a reactive free radical is generated, it can react with stable molecules to form new free radical, and these new free radicals go on to generate yet more free radicals and so on. So one free radical will generate 2, 2, 4, 4 will generate 8 and so on. And this is very, very, very damaging for the cell. It destroys it. Like, you can think of it like there's a building and you start taking out bricks from it one after another. What will happen to it? It will be damaged totally. Same is the case with cell. When produced in excess, these free radicals generate a phenomena called oxidative stress, and it's a very damaging process that can alter the cell membrane and other structures such as proteins, lipids, lipoprotein, and DNA. So what we can do about it? We can't let it be. We gotta survive. So we need a savior, someone who can sacrifice, and there comes the great hero on scene, the antioxidant. Antioxidant is like Commander Safeguard, the big brother. It goes to free radical and says, hey, you free radical, you're so restless, huh? Let me put you at ease. Give me that unpaired electron of yours and you go have some rest. Get done with this chain reaction of yours. So what it does is it scavenges. It captures that unpaired electron and then they start living happily. So where do we get these antioxidants from? Some of these are produced in our body. Our body cell naturally produce some very powerful antioxidant like alpha lipoic acid and glutathione, but they are not sufficient. It has been reported that our body needs around about 8,000 to 11,000 antioxidant units per day. And the deficiency of these can cause oxidative stress related diseases like heart diseases, type 2 diabetes, cancer, and so on. And they are very damaging to the skin as well. They can cause fine lines and wrinkles, a dull and uneven skin tone, and increases dark spots and causes sagging of skin. So it contributes greatly to the aging of skin. So eat carrots and spinach and berries And there are a whole lot of foods that can give you antioxidant. Go search them and start eating them. Stop eating junk now. Make a switch to healthy diet if you want to live a healthy and youthful life. Okay, now let's say you went to a jungle and you found this unique plant or a mushroom. And since you want to stay healthy and young and beautiful, you're staring at it and thinking, who are you, mister? What treasures are hidden in you? Do you have antioxidants in you? Are you the one who can keep me young and beautiful forever and ever? And if you do have antioxidants in you, how much are they? What is your antioxidant capacity? But since they don't speak our language, so no reply comes. So you start thinking of ways to know the answer to your questions. You plug it, put it in your backpack, and came back to your laboratory. And you start sniffing through pages, and then you come across a bunch of antioxidant assays. So now you know that there are a bunch of assays that you can use to determine the antioxidant potential, like DPPH scavenging assay, hydrogen peroxide scavenging assay, and so on. And then you choose DPPH because it is quick, easy, and cheap. DPPH assay is based on the measurement of the scavenging capacity of antioxidants towards DPPH. Let us now have a look at some of the features of DPPH. DPPH stands for 2,2-diphenyl-1-picryl hydroxyl. It is used to measure antioxidant capacity of several substances. It is purple colored and it's the stable free radical. It's mimicking the function of free radicals like the ones that are produced in our body, and it can only dissolve in organic solvents. We usually use ethanol or methanol to make its solution, and it turns yellow when its free radicals are scavenged by some antioxidant. Let us now briefly examine the mechanism of DPPH. So what happens is DPPH shows a strong absorption band at 517 nanometer. Now what is absorbance? Each and every single compound, here and hereafter. Okay, maybe I'm not so sure about hereafter, but every compound on the face of this earth has a specific absorbance. It has a fixed and definite capacity to absorb or transmit light over certain wavelength, and DPPH shows a strong absorption band at 517 nanometer. Okay, just in case if you are wondering how to measure absorbance, it is measured by using an instrument called spectrophotometer. So spectrophotometry is a method that's used to measure how much a chemical substance absorbs light by measuring the intensity of light as a beam of light passes through sample solution. Okay, so we were talking about the mechanism of DPPH, so let's get back to it. So the original color of DPPH is deep violet color, like when it is in the free radical form. So what happens is that when it reacts with the antioxidant, it is reduced by the antioxidant. That is, when it gets an electron from the antioxidant and its lonely electron pair gets paired, it changes color. जैसे वो कहते हैं ना कि वो तुम्हारी ज़िंदगी में क्या आया, तुमने तो रंग ही बदल लिए। तो कुछ ऐसा ही केस होता है DPPH के केस में भी, कि जैसे ही इसका जो एक सिंगल इलेक्ट्रॉन जो आउटर मोस्ट ऑर्बिटल में था उसकी पेयरिंग होती है, तो इसका कलर इमीडिएटली चेंज हो जाता है फ्रॉम डीप वायलेट टू पेल येलो और कलरलेस, एंड द अमाउंट ऑफ change in color depends on how much electron it has absorbed, and as it changes color, its absorption values will change accordingly. So before properly starting the experiment, there are a couple of things that we need to prepare beforehand. So the mushroom or the plant, whatever that you have plucked from the jungle, first of all you will dry it, then you will grind it, extract metabolites from it with the help of solvents, and prepare a stock solution of the extracts. Now, how to prepare a stock solution? You have to choose a quantity according to your will. For example, in this experiment, we will go for 0.01 gram sample in 10 ml DMSO, right? Secondly, you have to prepare positive control, that is ascorbic acid, in 0.01 gram or 10 mg in 1 methanol, right? So you may ask why we have to use positive control. It is because we need a standard for the sake of comparison. Ascorbic acid, it is also known as vitamin C. It's a very strong antioxidant, and there are other options that we can use instead of ascorbic acid, but in this we will go for this one. Next, you have to prepare reagent by adding 1.97 mg DPPH in 50 ml methanol, right? So we give it an incubation of around about 2 hours because its absorbance is unstable, and within 2 hours it will get steady. Afterwards, we have to fix its OD at 1, and optical density is measured at 517 nanometer. Right, and then we will use a blank cuvette for negative control. OD is measured at 570 nanometer, and negative control is used because we want to make sure that if we do find an activity, it is purely because of the extract and not the DMSO. That is the solvent that we have used to dissolve it and to make a solution of it. So first of all, we will make a table in the notebook for numerous extract dilutions that we have chosen. Here we have chosen 5, 25, 50, 75 and 100. One will be for the blank of for 200 microliter DPPH, and one will be positive control and the other will be negative control. Here we are preparing the reagent by adding 1.97 mg DPPH in 50 ml methanol. Here we are trying to adjust its OD at 517 nanometer. And now we are adding the respective concentration of our samples according to the labeling in the microtiter plate. Afterwards, we will add DPPH. DPPH is added in the dark because it's light sensitive. And then we will wrap it in the aluminum foil and incubate it for 1 hour. Now, have you noticed that change in color? The compounds with strong antioxidant capacity have reduced DPPH, and that has changed color from deep violet to yellow. Now, we will take OD of the microtiter plate at the same wavelength, 517 nanometer. These are the results. And now you can interpret these results by applying this formula. It is used to determine the percentage of antioxidant capacity of individual compound. AD here stands for the absorbance value of DPPH, the one that we have added as blank, and AS is the absorbance value of our compounds. And finally, thanks to Miss Cheyenne Naeem for her cooperation. And that's all for today. I'll see you in the next video. Love is.